All right, the next thing we're going to look at in this set of notes is truth tables. Truth tables are a way to look at the relationship, the true and false relationship in logical statements, and how when we combine them using our conjunction, disjunction, and implication, how it changes the true and falseness of the statement. So true and false, or truth tables, look at the relationship between logical statements and the operators. All right, using, negation, conjunction, disjunction, and I can't talk. Implication. There we go. All right, so the first truth table is the negation case, right? This is the negation. When we put a not or remove a not, right? So P would represent the original statement, right? This is the statement. And not P would be its negation. So if the original statement is true, its negation is not true. If the original statement is false, then its negation is true. And that's always the way it works, because these two statements are opposite, right? These are opposite of one another. So if one is true, the other is false. The negation of it's false. All right. So again, statement, negation. All right. So this one is two statements. All right. So statement 1, statement 2. So again, these are my statements. Then we use the word and. That's the conjunction. Or the word or, the disjunction. Or we do the if-then, implication. All right, and we want to see if my statements are true and false. How does that work when I do a conjunction between the two statements, a disjunction between the statements, and an if-then statement, since I can't say implication. All right, suppose my P and Q are both true statements. If they're both true, then the conjunction is true. The and statement is true, right? Right, that's what makes them true. Or is true, right? Because one or both have to be true in order for the or to be true. And then the if-then statement is true, right? If the right, it's P then Q. If the premise is true and the conclusion is true, then that statement is true. All right, well, now we're going to look at, now we have to be careful. So P is true, Q is false. So when we do P and Q, well, that's false because one of them came out false, right? And the and statement both have to be true in order for that statement to be true. So if one of them's false, the whole thing is false. The or statement, though, one of them's still true, and so in the or statement, that is still true. I just need one of them to be true in order for my or to be true. All right. Then the if P, then Q, I have to read what order it works in. So remember, P is true, but Q is false. That's the false case, and that's the only false case for if then Q. All right. So again, that's the false. If P is false, P is false. Sorry. If P is true, Q is false. Then the if then is false, right? Because the concluding statement was false, and the initial statement was true. All right, the next one. P is false, Q is false. All right, well, the and statement's false, because again, one of them's false, the whole thing's false. Or is still true, though. One of them's true. This time Q is true. All right, then the if P, then Q. That's the hard one, right? So this time, the premise is false, but the conclusion is true. Well, that's true, right? The premise, sort of, we throw that one out, and then we just say if the premise is false and the conclusion is true, that is true. All right, the last one. Both statements are false. And statement's false, or statement's false. However, so again, and statement's false because they're both false, or statement's false because they're both false. But the if P then Q, when both statements are false, that's true. If P is false and then Q is false, the implication is true. If P then Q is true. All right. And this one missed the not Q here. So this is kind of doing our negation with the and or. logical operators. All right, so P is true, and so then we're going to look at Q, and so we want Q to be opposite. So I'm going to let Q be true, then Q be false, Q be true, Q be false. So I've got all the different ways. So both are true, both are false, one's true and one's false, all right, in different orders. All right, so that's what I've got to make sure my truth table is. All right, so the first part of this table, all right, so again, I had to make sure, so I did TF for the Q, because again, I wanted all the different types of statements. So both statements are true. One statement's true, one statement's false, and I wanted to make sure I do it in different orders. So P was true, Q was false, P was false, Q was true, and then both statements are false. All right, so the next table is the negation. All right, not P. So I only really need to look at the P part of the table. Remember, the negation is the opposite. So if P is true, not P is false. If P is false, not P is true. And so it's the exact opposite of the first list. False, false, true, true. All right. Now the next one is looking at the negation of P paired with the and statement, the Q. All right, so I've got to look at the not P and Q statements. All right, so the first one, so again, as soon as I see a false statement with the word and, false. So the first statement is false because not P is false. All right, the next one is both are false, so that's false. The next one, both are true. Q is true, not P is true, so the and statement is true. And then the last one is false because not P is, or sorry, Q is false, not P is true. All right, so there's false, false, true, false for that table. All right, then I added the not Q, so this is the not Q because the last thing I'm going to look at is not P or not Q. All right, so not Q, so again, I look at the Q statement and put the exact opposite. So if Q is true, not Q is false. If Q is false, not Q is true. If Q is true, false. So again, it needs to be the exact opposite of that second list. All right, now I'm going to look at these, and I'm combining them with the or statement. So I'm doing the negation of P, the negation of Q, and I'm combining them using the or, which means as long as one of those two statements are true, it's a true statement. The only time it's false is when they both turn out to be false, which is the very first line, right? Not P was false, not P was false, or not Q was false, so that's false. All right. The rest of them should turn out to be true, but you should check it out. Not P is false, not Q is true, true. Not P was true, not Q is false, but since I had one true, that comes out true. In the bottom part, both of them are true. Sorry, I'm supposed to look at these two lists. Those are the two lists I'm using for this table. True, true, all true. So again, the only time it's false is when both of them came out false, because the or statement, as long as I get one true statement, the whole thing turns out to be true. All right, the last example of a truth table. All right, the implicit stuff, right? If, then, which is always the harder stuff with our complements. All right, so remember, the only time it's false is when if is false. Sorry, if is true, then the conclusion is false. All right, so that's the one we have to watch out for. Otherwise, it's a true statement. Okay. Just so that you know what these are, this is the conditional, the original conditional. This would be its converse. This would be its inverse. And this would be its contrapositive. Alright, so let's see which one of those are true and false. Alright, so first, same list we had before. P is true and false. Q is true and false. Alright, so then the complement. So I use the P list and basically do the exact opposite. So again, true, true, false, false, false. And maybe I'll switch colors. Alright, then the not P would be using that. It's the exact opposite. False, true, false, true. Alright, so the conditional first. So the conditional looks at P is the premise, and then Q is the conclusion. So again, the only time it's false is when P is true and Q is false. So I look for the case where P is true and Q is false, well, that's this example. P is true, Q is false, and so that's the only time the if then is false. So then the rest of that's true. All right, next one, the converse. When is it true and false? So this time we flip it, and so this time because we're flipping it, the hypothesis is Q and the conclusion is P. And so again, the time that this one is false is when Q is true and P is false. So I'm looking for when Q is true and P is false. Well, that's this part. Q is true, P is false, so that's the first case. The first case is false, and that's the only time it's false. Every other time it's true. That's the only false outcome. So that goes false, true, true, true. All right, now the inverse. Not P and not Q, so I'm looking at the nots. And so I'm looking at these two lists in order to do my last two truth tables. All right, so not P, not Q. So the only time this is false is when not P is true and not Q is false. So I've got to find when not P is true and not Q is false. So not P is true and not Q is false. Well, that's the first one here, right? And so that's false. And that means the rest of it's true. All right. The last one. Not Q and not P. So the contrapositive. So this time, the only time this statement is false is when not Q is true and not P is false. All right, so I've got to go find when not Q is true. Not Q is true, but not P is false. That's right here, right? Not Q is true, not P is false. And so that's the statement. That's false. It means the rest of them are true. All right, and that's the filling out the truth statement. So what you should notice here is if you look at your truth tables, this and this truth table comes out the same, using the same P's and Q's. This is the same. And then look at the conditional and the contrapositive. They're the same. And it should make sense that they're the same because the conditional was PQ. The contrapositive, we flipped everything, right? We flipped P and Q, and we've negated it, right? And so again, not, it's kind of like a double negative. It makes it the same, right? And the middle statement's, again, the same thing, all right? Because we flipped it. It has the exact same truth table as when we negate it, all right? So flipping the premise and conclusion has the exact same truth-false table as when we negate the premise and the conclusion. So the converse, inverse, same truth table. The conditional, contrapositive have the same truth table, and I actually state that over here. All right, so the conditional and the contrapositive have the same truth value. So if the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false. The converse and the inverse have the same truth table. So if the converse is true, the inverse is also true. If the converse is false, the inverse is also false. All right, and so that sort of finishes. That's the end of sort of the notes, and then I'm just going to do more examples just so that you're kind of aware of how questions can be asked in this section. All right, so we're putting it all together, but that's going to be my last video lesson, so I'm going to do that in my next video.